Okay, so welcome everyone. My name is Kyle Lake. I'll be presenting today, and today's webinar is going to be on physical design reuse in PAD, Standard, and Standard Plus. So this will be covering how to reuse circuits both in the schematic as well as routed circuits in the layout tool for PADs layout utilizing DX Designer as a schematic capture tool. Okay, so hopefully we're going to accomplish today how to set up and reuse circuits in the PADs flow. Okay, again, so that's with DX Designer as the schematic capture tool, as well as PADs layout as the layout tool. Okay, so we'll talk about that in the PADs layout, as well as reusing actual schematics in the DX Designer schematic capture tool. Okay. Also, we'll just be covering on how to reuse those PADs layouts, reuse circuits that we save in future designs. So it's really powerful and really easy to actually save those and reuse them in circuits that you're designing in the future. Okay. So just a little bit about Oasis Sales. Again, my name is Kyle Lake. I work with Oasis Sales. And if you're unfamiliar with that, Oasis Sales is a premier Mentor Graphics, now a Siemens company, reseller, and we have been for over 18 years. So our main territory is the Midwest and Northwest of the United States. So you can see all those states that we service down below. We cover tools ranging from electronics design like PADs and Expedition to simulation, hyperlinks, all the way to Model Sim and Questa for your FPGA verification. So also we are teamed with this webinar series with TriLogic. So TriLogic is our counterpart in the east and northeast side of the United States. Again, they've been with Mentor Graphics for over 30 years, and they can offer the same types of services that Oasis does, and you can see their states that they service down below. So again, they are happy to also work with Mentor, now a Siemens company, and they're headquartered in Andover, Massachusetts. Here's just a little graphical representation of our respective territories. Again, you can see TriLogic on the east and southeast, as well as Oasis Sales in the northwest and midwest of the country. So if you're unfamiliar with who to get into contact, if you need more information on evaluating the tools or just have any general questions, please feel free to reach out to me. I'll have my contact info in just a few slides. More than happy to discuss further solutions or tools, or answer any questions or get you in contact with the correct personnel that you're looking for. We do host quite a few webinars, so I see some familiar names in our attendees dialog box now. So thanks for continuing to attend our webinars. We strive to really provide a lot of useful information to help you be more successful, save more time in the tools, and design better electronics. So we are really happy to have all of these archived webinars up on our YouTube channels. So you can find either of those just by searching for Oasis Sales or TriLogic on YouTube, or go to our website as shown below, and you'll be able to find a link to either of those. So I just wanted to throw a little blurb out there for the next webinar I'll be hosting, and this is going to be a little bit over a month for me, and that's going to be Thursday, February 21st, same time, and I'm going to be talking about how to correctly assign models for Hyperlinks SI. So Hyperlinks, if you're unfamiliar, is a signal integrity simulation tool, and it does a very good job, but as long as you have the correct models assigned for that. So simulation really is only as good as the models that you have, so I just want to make sure that we're all correctly assigning models and using the best models possible. Here's my contact information. If you have any questions, please feel free to reach out to me. Take maybe a screenshot or jot that down. I'll show this at the end of the webinar as well. I'm always happy to help with any types of questions. Okay. And as far as the questions during the webinar, please feel free to type those into the chat box. I do have everyone muted on the line today just because we do have quite a few attendees, so I didn't want any extraneous noise on there. But if you have any questions, comments, anything like that, please feel free to put that in the chat box. And if it's relevant to what I'm talking about, then I will definitely get to it. Otherwise, I'll follow up with you just in a few days with more information on what you're asking about. Okay, so without further ado, let's hop into the actual webinar again on PADs Design Reuse. just a little bit of a blurb on what kind of tools we do cover in the Mentor graphics space. Maybe you're unfamiliar with Mentor graphics rules or tools, or just interested in learning a little bit more about what we can offer you in the electronics design space. Okay, so today we'll be talking about that middle left one, PADS. So PADS is a project-based PCB design tool that is a very powerful layout environment that you can do some very complex designs, but it really doesn't require a super large IT infrastructure to actually implement, or requires a large team to actually work with and have data management capabilities. Okay, Expedition, on the other hand, is our enterprise PCB tool. It, again, has unlimited horsepower on the layout tool. It can really do some very complex designs, as well as has a lot of great concurrency designs, so multiple engineers can be in the same layout at the same time working on different circuitry. Okay. On the flip side of the design space, we actually have hyperlinks, and hyperlinks is an industry standard for PCB analysis and verification. What you can do with hyperlinks, it's actually a family of tools. So within the hyperlinks family, we have hyperlinks signal integrity for digital signal integrity validation, as well as DRC for EMI and EMC sign-off, and power integrity as well for both DC drop and AC coupling. And then on the back end of PCB manufacturing, there is the Valor tool. So what that allows us to do is check for DFM and assembly checks to make sure that your yield is going to be as high as possible when your boards are actually sent to the manufacturer. Okay, so just understanding what design reuse really is. So there's two types of design reuse, and I'm going to be talking about both of them today. And that is first, schematic reuse. Okay, so schematic reuse, pretty easy to understand. We just want to reuse a schematic or sheet from an existing project. I've seen many different customers utilize this in different ways, and I'm personally going to talk about what I think is the best way to go about this in order to make it the easiest to use. Okay. Also, on the layout reuse, I'm sure a lot of people are familiar with why we would want to reuse layout. So if you have an analog circuit that's been routed and fully validated, why do we want to have to redo that in a future design, or a power supply, anything like that? So we can save that fully routed design or fully routed circuitry in your design and use it in future designs. Very easy to set up and use, and hopefully I can convey that today. All right, so hopping into schematic reuse, and I do see a question from Raul who says, is this going to be relevant to version VX 2.3 or VX 2.4? That's a great question. What I'm going to be talking about today works all the way back to before 9.5, so that's a 7-year-old version right now. So any of the version that you're on should work with the functionality that I'm showing off today. Okay, so schematic reuse, PADS Designer, which is the schematic design tool included with PAD Standard, Standard Plus, as well as Professional and Expedition. So DX Designer is the front end for all Mentor graphics layout tools. Okay, so PADS Designer allows for us to really easily copy and paste circuitry from other designs. And there's really 3 major ways that we can accomplish this. Okay, so the first one, and my preferred method, is by going File, Open, Block in your current design that you're working on. This allows us to actually point to a different project file and open up a single schematic and copy in the circuitry that we want from that target design into our source design. Also, we have the ability to open up multiple instances of the schematic capture tool, and you can just have one window open up on the right, one open on the left, and copy and paste to either of those. Also, we can use the Project Navigator to actually copy and paste whole sheets or blocks. So the Project Navigator shows all of the different schematic sheets, and you can just right-click on one of those sheets, hit copy, and then go to your target design and hit paste. So Raul, you must be using hierarchical designs, and if you're familiar with hierarchical design in DX Designer, this type of schematic reuse will work for both flat designs as well as hierarchical designs. So really the functionality doesn't change between those 2 types of designs that you're working with. Some very useful settings for copying circuitry in the PADS Designer space. Okay, so this is not just useful for when we are trying to reuse schematics. It's also useful if we are trying to copy decoupling capacitors, or any type of logic that you want to copy in from one sheet to another. Okay, and these can be accessed in Setup, Settings, Advanced section in VX Designer. And those settings that I think are very important for this type of functionality are preserve packaging info on copy. And what that'll allow us to do is, if we're copying from one design to another, we may want to preserve the reference designators that have been assigned in that design. So that can be very powerful. And that's just a really easy checkbox that we want to say, yes, preserve that packaging info on copy. The next one that I like to talk about within design reuse is unique names on copy. So again, when we're copying circuitry, this will, if we have this checked, it will provide a new unique identifier for those copied objects. Okay, so that includes components and nets. So if we do want unique names on the copy, the actual nets will get a new net name. So that can be a good and a bad thing. Right. And the last thing that I like to talk about is copy constraints on copy sheet. And what this does is, if you have any constraints assigned to a schematic sheet, those will be copied over. One caveat to this is that only applies when we are working with the Navigator copy. So that's when you're copying an actual sheet using the project Navigator, that will copy those constraints assigned there. And Joseph, I do see your question about these advanced settings. There is no different way to change those. You do have to go to Setup, Settings, Advanced in order to change those. Okay, so I wanted to talk, so in that last page, we talked about 3 different ways to do the copy paste of our circuitry. Okay, and I'll show off 2 of those today. The first one is File Open Block. And again, we can select the area of circuitry to be copied. That's powerful because if we don't want everything on that schematic sheet, we only have to grab a certain functionality of that sheet. Okay, so you can kind of see in that matrix down below the differences between File Open Block and the Navigator copy paste. Okay, so the main settings, the main difference between these 2 are going to be the constraints. Okay, so the only way we can copy constraints from project to project is by doing the Navigator copy paste, by copying in the entire sheet. And if this information is useful, again, we will have this webinar on our YouTube channel, so you can always review this in the future. Okay, so here I wanted to outline really the steps that we need to do in order to actually do some design reuse within the pads flow. Okay, so in pads layout, I first want to talk about the location of where our reuse circuitry is going to be saved. Very easy to identify that, and that's in Tools, Options, File Locations. Okay, so this will have a reuse location shown, and just usually by default it's in C Pads Projects Reuse. So you can see down there at the bottom left, that's the Tools, Options, File Locations, and you can see that Reuse section is in C Pads Projects Reuse. Okay, so in the pads layout space now, we want to create that .ru file, which is that reuse file. I like to, in the layout environment, right mouse button. So RMB is right mouse button and click on filter. Okay, so right mouse button in space and pads allows us to have a selection filter. And then down near the bottom, we actually are able to hit on the filter icon, which allows us to click on the individual design units that we want to be able to select. I always recommend selecting parts, pins, traces, vias, and I put traces on there twice. So I always like to make sure those are selected, and it again depends on what you want to have in that reuse circuitry. You don't have to include traces or vias. We can just have the parts, and the actual orientation and placement of how those components are placed on the board will be saved in that .ru file. Okay. Once you have all the units or the objects that you want to save into that reuse file, all you have to do is hit right mouse button and make reuse. This will allow us to save that RMB or the RU file to disk and reuse it in future designs. So in the target design, forward annotate to make sure all of our necessary reuse components are in the layout tool. And then with the design toolbar, we're going to make like reuse and navigate to the .ru file. If everything's set up correctly, you should maybe get some warnings if there's mismatches in the layer stack up or anything like that. And hopefully everything will pop out for you to have the exact same circuitry laid out, routed the exact same way that you used it when you had to make reuse. Okay, so what is PADS comparing between the design and the physical design reuse? Okay, so it can be very confusing as to how this functionality actually works. And this is what the tool is checking on between the source design of the .ru file and the target design where we are trying to reuse that. So first, it makes sure that the layer definition is set up correctly. We do have to have the same number of layers in the target and the source. And then it's going to start looking at the actual components in the reuse files. Okay, so I've got, first it's going to check the part types to make sure that the part types are set up correctly. Then it's going to make sure the PCB decals are the same as well. Then it's going to see if any components need to be added. It's going to form the pin pairs, and pin pairs again are the connections from pin to pin on components. Then it actually checks to see which routes need to be added, as in the traces that are going to be added to that .ru, and then the design rules if necessary. Finally, it will add any polygons or text items, such as if you just have any random text on your silkscreen layer, if you chose that to be in your reuse file, or any other type of graphic that you want to save. All right, so the elements that we can contain in a physical design reuse, I think this is my last slide before I hop into the demo. First, we have the component elements, so the part type, the decal, any vias, anything like that. And then we're actually going to the routing objects of traces, buses, anything like that that you have the fan out pattern, it's going to add those. And then drafting objects such as polygons, text, anything like that. Unions and arrays, and then finally, it's going to add in those net-based design rules. Okay, so now I'm going to hop into the demo section of our webinar today. And I do see a question from Vitaly, and I see the design reuse steps, are they the same in the Expedition layout space? No, they are not, as far as reusing the layout circuitry. Everything that I show you within DX Designer, though, will be usable in the Expedition flow for copying circuitry and reusing circuitry there. Okay. All right. So I'm going to go ahead and open up a design that I want to first create a golden circuit from. All right, so I'm going to actually use our PAD standard evaluations as a great starting point to begin learning how to use the tool. Okay, so I'm going to open up lesson 32, which is a fully routed design. And you can see there's a lot of circuitry in here. And the section that I want to reuse is this analog section in the top right of our design. Okay, so again, first I want to make sure I look at tools, options, and file locations. Okay, so this is again the reuse section of the where we are going to save the .ru file that I have. Okay, so that's very important, and that's really the first step that we need to make sure that we're pointing to the same location in our target design and our source design where we're trying to place that reuse circuit. Okay, so the next step that we had in creating some circuitry here is I'm going to right mouse button in space to bring up my selection filter. Okay, so within the PADS flow, this brings open that selection filter. And what I like to use here is the filter. This is really useful because if I just select components, I'm not going to be able to select the traces as well as the actual footprint. So now if I go down to the filter, this actually brings up a very easy to use filter here by design object. So I can click on parts, pins, traces, vias, and anything else you want to kind of save into that reuse folder, we can save it here. We also have the ability to have selectability on a layer by layer basis. Okay, so once I have what I want to have selected there, I'm just going to area select all of this circuitry. You'll see that it selects everything that I just had selected. Now all I have to do here is right mouse button and we'll see a make reuse. Okay, so now once I click on make reuse, it's going to pop open the reuse type make reuse dialog box. So there's two options that I can do within here. Deselection report is grayed out, but that would show anything that is unselected from what I had selected because we cannot save it into a reuse file. Selection report, if I click on that, actually gives us a text file of exactly what's going to be saved in that reuse folder. Okay, so just to double check to make sure you have everything that you wanted selected, really easy to say that there. I'm going to go ahead and name this analog_block and just hit OK. All right, so that allows us, again, it points to that tools, options, file locations for our reuse folder. Okay, so I could save this potentially to a different block if I wanted to, or a different file location. You just got to make sure you remember where I put that. Okay, so I have created that reuse block now. And now I'm going to create a brand new project within the DX Designer space and actually copy in that circuitry. So I'm going to close pad layout, and I'm actually going to show first the Navigator copy that I was talking about prematurely. So I'm going to open up two instances of Pad Designer here. And this will only work if your licensing is set up as node locked or you have multiple floating licenses available. That's the only way you can have multiple instances of Pad Designer open up at the same time. Okay, so on the left-hand side, I'm going to go ahead and create a reuse project in my C desktop reuse folder. Okay, so I'm going to go ahead and create that. And on the right-hand side, I'm going to open up the PRJ for the PCB file that I just created that reuse block from. All right, so on the left-hand side, I have my totally blank schematic sheet. So this is totally blank, brand new project. On the left-hand side, you'll see I have an actual project with a bunch of different sheets here. Okay, so I want to push into this analog sensing block and actually copy this into this schematic here. Okay, so what I can do, first I want to go to my setup settings and look at my advanced settings again. Okay, so remember the important setup settings that I'm talking about here, mainly in this example, is preserving packaging info on copy. Okay, so I do have this checked, and once that's checked, whenever I copy a component, it's going to save that reference designator that we have there. Okay, so all I have to do in here is group select my design components, do a Control-C, go to my target design, Control-V, and you'll see I have all of that circuitry just like that. Okay, so that's one of the methodologies that we can do for reuse circuitry. I'll go ahead and create the PCB now and show how we can actually go about that. I'm going to close that right-hand project. And you can see that the schematic is a little bit too small for all of the circuitry that we have in here. And a really easy way to change the sheet size, I'm going to double-click in space right there to open up the properties window. And you'll see I have a drawing size of size B right now. And now we'll change this to a drawing size C. Okay, so very easy to go ahead and change that on the fly. Now I'm going to open up a brand new pads layout setting or instance. And I'm going to create a brand new blank PCB. Okay. So I'm going to just use the system default startup file. If you're unfamiliar with startup files in the PADS layout space, it essentially sets up your stack up and design rules, and then some other settings as well that you can have in that startup file. Okay, so the first thing I'm going to do here is I'm going to right-click on the toolbar in order to bring up my drafting toolbar. Here, I'm just going to create a board outline very quickly and in a rectangular fashion. So nothing special going on here. Just going to create a small board outline. So now I have my schematic and my PCB open up side by side. I'm going to do a quick save as and save this into my reuse folder. All right. So to ensure that I'm connected to this schematic, I am utilizing the netlist flow in the PADS standard format. So I'm going to click on Tools, PADS Designer. It understands which PCB I'm pointing at to correctly right now. And now I just have to browse to my reuse project that I was working on. Connect there, and we should be good to go. So all I have to do within here now is I'm going to go to the ECO toolbar and hit Add Reuse. All right, so this will again point to my reuse folder location. All right, so I can point to a .ru file, and I had that analog block. Open that up, and it's going to give you any errors or warnings that is found. And I think I know exactly what this error is going to be, and we will see that we have a layer mismatch. Okay, so in the design I only have 2, in the reuse I have 6, and very easy to change that. I can go set up layer definition. In order to change layers, all I have to do is click on modify here and change this to 6 layers. Okay, so this might cause some concern for people, and what that is, if you don't want to have to change the layers to make them the exact same, what you can do is save a reuse file, make that into a PCB, break the reuse, change the layers in that PCB, and then save the reuse file in that different layer definition. It just makes sure that you're not going to be pasting in reuse files from a 12-layer board that utilizes almost every layer into a 4-layer board. You're going to lose a lot of the internal layers there. Okay, so now I should be able to go back to that ECO toolbar, hit Add Reuse, and again, click on the .ru file that I want. So now we'll see 0 errors, 54 warnings. Again, if I want to look at that report file, it can pop open here. And most of these are going to be different layer names or dielectric constants are different. I think that's all that we have here. So for example, this one is routing direction, just a layer biasing routing direction here. So that's not really that much of a concern right now. I just want to go ahead and hit continue. And you'll see that just like that, it has copied in that analog block that we had from that source design. Okay, so now if I select on a component and click on that component, you'll see we have cross-probing capabilities directly between the schematic and the PCB, just like that. Okay, so if I select this op amp, it'll select the correct footprint there. Okay, so that is our first design reuse that we did. Very easy to do that, just like that. Okay, so that's a pretty easy example. Now I kind of want to show another example of how to utilize DX Designer in a different fashion to utilize it, the copy circuit functionality in a different way in the actual designer space. Okay, so first I'm going to save this PCB, and I'm actually going to open up a different PCB design. So this is going to show how we can use reuse circuits from different types of PCBs. Okay, so I'm going to go File, Open. And I can go Documents, Demos. I'm actually going to be using the BeagleBone Black. And what this is a reference design off of pads.com. So if this seems like an interesting design to work with, please take a look at pads.com and you can actually download this design as well as the schematic. So I'll actually open up the schematic as well. that's associated with this PCB, so we can actually do some cross probing through here too. So what this is a microcontroller, mini computer, with some DDR memory, LED interface, USB, and it's a pretty powerful little computer here that we can play around with in the pad space. So all I did with this is I just downloaded off pads.com and I was able to start working with it. Okay, so exactly what I'm gonna try and copy here is our LED configuration circuit here. So that's just here on the right-hand side of what I've got going on. Again, in order to allow for cross-probing, I'm just gonna hit browse to the correct PRJ. Connect to it, and now we should have cross-probing capabilities. Okay, so in that first example, I area selected a group of components and saved it to reuse. Okay, so this time I'm actually going to show how we can do that based off of the schematic. So I'm going to use my selection filter here at the top. If you do a pull down on the selection filter, we have the ability to have these preset selection filters. I'm going to just select symbols first. And all I'm concerned about is this resistor, LED, and the actual MOSFET that is driving this circuit. Okay, so I have to make sure I select all of those components, and you'll see they highlight on the board for us. Okay, so now I have all those components, but if I want, I can actually change my selection filter back to all, and in the schematic, I can actually start selecting these nets, and you'll see now if you're paying attention here, it's selecting the traces in the pads layout space. So this is an easy way to actually go by your schematic and understand what is going to be saved into that REU file. Okay, so that looks good with my LED configuration. If that's all I want to have in my reuse file, that's totally fine. I can just hit right mouse button again, make reuse. And this time I'm going to call this LED config. This time we do have a deselection report. In the last example, that was grayed out just because it didn't deselect anything. And you can show and see in here that it's just not selecting digital ground, that pin pair, which is a good thing. It's got 624 pins and 349 connections. We don't want to have that in our reuse file. That would be a lot of information being saved into there. So again, I'm going to hit OK and save this to my file. Okay, so that's all I had to do in my source design for this reuse file. This time, again, I am going to open up that reuse project that I just created. So now I'm going to go File, Open PCB, go back to my desktop for that reuse location, the reuse project _ Kyle, open up my reuse PCB, and the reuse project. Okay, so now I want to copy in the actual schematic circuitry in the pads designer space. This time I am not going to open up 2 total instances of DX Designer because that's really, I don't think, the best way to go about it. My preferred way, first I'm going to make sure I have a new schematic sheet, which I do. I do believe I opened up the wrong project here. Okay, so I'm going to go back to my desktop, reuse project Kyle. Okay, so now I want to create a new schematic sheet. All I have to do there is go File, New Sheet, and you'll see we have on that 1.1 sheet, I have my analog circuitry. Here on this 2.2 blank circuit that I want to copy and paste in the LED configuration that I just made the reuse file. Okay, so to do this now, I'm going to go File, Open, Block, and this is my preferred methodology on how to do this. So now this opens up my Open Block dialog. So right now it's just looking in that current project. Here I can down-click and do on the Browse functionality. And this will actually allow me to browse to a different PRJ file. So this time I'm going to navigate to my BeagleBlown PRJ file. So you'll see as soon as I double click on this PRJ, it opens up all of those different schematic sheets that I had in that particular project. Okay, so now I'm going to open up that LED configuration/reset schematic sheet. If I hit open, that will actually open up that schematic sheet that we were just working. So you can see this is the BeagleBlown project in the bottom right. And you'll see at the top, this is in a read-only fashion right now. Okay, so that just knows that we've opened up a different block from a different project. I want to make sure I have my selection filter set to all. And all I have to do within here is group select this circuitry here. That was all right. So it's not allowing me to select it right now. There we go. Okay. So I've got that selected. All I'm going to do here is do a Control-C. So again, read only. This is that open block that I had. I'm going to go back into my design reuse block and do a Control-V. Okay. So that pasted that particular circuitry that I had within there into my target project. Okay, so that's my preferred way to actually copy circuitry in from project to project by going File, Open, Block. I think it's a little bit easier. We have a lot more control of exactly what we're selecting. It just makes it a simpler process. Okay, so now that I have my circuitry in my schematic, so I've got this analog block. Again, if I connect my PCB to this project, I have cross-probing capabilities for these different components. But now I need to bring in this LED circuit. Again, I'm going to go to the ECO toolbar, hit OK, and I'm going to hit the Add Reuse button. Okay. So again, this will allow me to navigate to the reuse files that I have saved. I'm going to this time click on the LED, 0 errors, 67 warnings. That's fine. I'm going to not look at that report file. OK to continue. OK. And there we have our LED configuration circuit. Okay. So that's the exact same configuration that we just had in that source design. I can now actually start doing any other schematic sheets that I want and start doing new instances of a reuse block. Okay, so that is all I was planning on showing today. If there are any further questions, again, here's my contact information. Please feel free to reach out to me and ask any questions, or if you need any contact information for your account manager or your technical resource, I'm always happy to answer that. Again, this is going to be on our YouTube channel, so we'll send out a blurb with a link to that and some other information on this. And if you, again, have any questions, please feel free to reach out to me. Thank you, everyone, for attending. Hope you have a great rest of your day.